Probability. Different examples. Let us study probability with different examples. Now, let us take an example related to playing cards. Students, have you seen a deck of playing cards? It consists of 52 cards which are divided into 4 suits of 13 cards each. Spades, hearts, diamonds and clubs. Clubs and spades are of black color, while hearts and diamonds are of red color. The cards in each suit are Ace, King, Queen, Jack, 10, 9, 8, 7, 6, 5, 4, 3 and 2. Kings, Queens and Jacks are called face cards. Let us take an example. One card is drawn from a well-shuffled deck of 52 cards. Calculate the probability that the card will be an ace, will not be an ace. Well, shuffling ensures equally likely outcomes. There are 4 aces in a deck. Let E be the event, the card is an ace. The number of outcomes favorable to E equals 4. The number of possible outcomes is equal to 52. Therefore, N of S is equal to 52. N of E is equal to 4. Therefore, P of E is equal to number of outcomes favorable to E divided by number of all possible outcomes. P of E is equal to 4 upon 52 is equal to 1 upon 13. Let F be the event, card drawn is not an ace. Card drawn is not an ace means that other than ace. Therefore, the number of outcomes favorable to the event F is equal to 52 minus 4 is equal to 48. Therefore, P of F is equal to number of outcomes favorable to F divided by number of all possible outcomes is equal to 48 upon 52 is equal to 12 upon 13. Note that F is nothing but E bar, that is E complement. Therefore, we can calculate P of F as P of F is equal to P of E bar is equal to 1 minus P of E is equal to 1 minus 1 upon 13 is equal to 13 minus 1 upon 13. The answer is 12 upon 13. Let us take another example. A box contains 3 blue, 2 white and 4 red marbles. If a marble is drawn at random from the box, what is the probability that it will be white, blue, red? Saying that a marble is drawn at random means all the marbles are equally likely to be drawn. Therefore, the number of possible marbles in a box are 3 plus 2 plus 4 equals 9. Therefore, number of possible outcomes is equal to 9. That is, N of S is equal to 9. Let W denote the event the marble is white. B denote the event the marble is blue. And R denote the event marble is red. As there are 2 white marbles in the box, therefore, the number of outcomes favorable to the event W is equal to 2. So, P of W is equal to 2 upon 9. As there are 3 blue marbles in the box, therefore, the number of outcomes favorable to the event B is equal to 3. So, P of B is equal to 3 upon 9. Since there are 4 red marbles in the box, therefore, the number of outcomes favorable to the event R is equal to 4. So, P of R is equal to 4 upon 9. Note that P of W plus P of B plus P of R is equal to 2 upon 9 plus 3 upon 9 plus 4 upon 9 is equal to 2 plus 3 plus 4 upon 9 is equal to 9 upon 9. The answer is 1. Did you observe that in all the examples discussed so far, the number of possible outcomes in each experiment was finite? There are many experiments in which the outcome is any number between two given numbers, or in which the outcome is every point within a circle. Can you now count the number of all possible outcomes? As you know, this is not possible, since there are infinitely many numbers between two given numbers, or there are infinitely many points within a circle. Definition of probability cannot be applied in the present form. How to solve such questions? Let us consider following examples. In a musical chair game, the person playing the music has been advised to stop playing the music at any time within 2 minutes after she starts playing. What is the probability that the music will stop within the first half minute after starting? Here, all the possible outcomes are the numbers between 0 and 2. N of S is equal to 2. This is the portion of number line from 0 to 2. Let E be the event that the music is stopped within the first half minute. The outcomes favorable to E are points on the number line from 0 to half. The distance from 0 to 2 is 2, while the distance from 0 to half is half. Since all the outcomes are equally likely, therefore, for the total distance of 2, the distance favorable to the event E is half. So, P of E is equal to distance favorable to the event E divided by total distance in which outcomes can lie is equal to half upon 2. Therefore, P of E is equal to 1 upon 4. Let us take one more example. Two dice, one blue and one grey, are thrown at the same time. Write down all the possible outcomes. What is the probability that the sum of two numbers appearing on the top of the dice is 8, 13, less than or equal to 12? Solution. When the blue dice shows 1, the grey dice could show any one of the numbers 1, 2, 3, 4, 5 and 6. The same is true when the blue dice shows 2, 3, 4, 5 or 6. The possible outcomes of the experiment are listed in the table. The first number in each ordered pair is the number appearing on the blue dice, and the second number is that on the grey dice. So the number of possible outcomes is equal to 6 into 6. Therefore, N of S is equal to 36. The outcomes favorable to the event, the sum of the two numbers is 8, denoted by E. Check the highlighted diagonal pattern table. The sum of each outcome is 8. That is, 2 plus 6 is equal to 8, 3 plus 5 is equal to 8, 4 plus 4 is equal to 8, 5 plus 3 is equal to 8, 6 plus 2 is equal to 8. Therefore, E has elements 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. Therefore, n of e is equal to 5. Therefore, the number of outcomes favorable to e is equal to 5. Hence, P of e is equal to number of outcomes favorable to e divided by total number of outcome. Therefore, P of e is equal to 5 upon 36. The highest sum of the outcome is 6 plus 6 equal to 12. As you can see from the table, there is no outcome favorable to the event f. The sum of two numbers is 13. So P of f is equal to 0 upon 36. The answer is 0. As shown in the table, all the outcomes have the sum less than or equal to 12. Therefore, all the outcomes are favorable to the event g. Sum of two numbers less than or equal to 12. So, P of g is equal to 36 upon 36. The answer is P of g is equal to 1. That's all in this topic, students. Learning is fun, so keep learning.